and welcome to Tag One Team Talks, the podcast and blog of Tag One Consulting. Today, we're going to be discussing the practical side of load testing, and we're going to walk you through how to analyze load testing results using New Relic so you can find the problems that are impacting your site and address them yourselves using the Goose load testing framework. For our example today, we're going to be load testing the Drupal framework in CMS with the default Umami install, and we're going to be trying to find a performance problem in Drupal core that we're, of course, then going to fix. I'm Michael Myers, the Managing Director of Tag One Consulting, and joining me today are two of our performance and scalability experts, Jeremy Andrews, the founder and CEO of Tag One and creator of Goose, and Fabian Franz, our VP of Technology, a major contributor to Goose, and the man responsible for a lot of Drupal's performance and scalability capabilities. Jeremy and Fabian, welcome. Thank you guys for joining us again. Before we get started, I just want to say a quick thank you to Pantheon. Pantheon.io is providing us with a lot of free hardware for our Drupal instances. We're using their elite instances with their global CDN, which is a huge asset when you're throwing a lot of traffic at websites. So thank you, Pantheon. Jeremy, can you give us a quick intro and background on the plan?
Yeah, hello. So today we're going to, as Michael said, we're going to run a quick Goose load test against an Umami site. It's Drupal with the standard Umami install. Goose is running on a R5N 8X large EC2 instance. So I will be connecting in there right now and get this set up to make sure everything is working. I've pre-typed a command here. I'm in the Goose directory. The first thing I did was I actually increased the U limit because when simulating lots of users, you can run out of resources if you don't do that with the standard install. We're using Cargo, Rust's package manager to launch Goose. And we're building the example that's in there. So it's an unmodified version of Umami. We run against the host, which is live-tag1-umami.pantheonsite.io. The -v shows the output. I'm going to start off with just running with 3 users just to make sure everything's working. And sure enough, it should kick off quickly, log us in. Once it's all up and running, it spits out some statistics. And now it's running a load test with just the 3 users. I chose 3 users because this particular load set is configured with this example has 3 users. It has anonymous user browsing in English pages. It has an anonymous user browsing Spanish pages. And then it has an admin user that actually logs in and posts a couple of things. So with it all up and running, I'm going to go ahead and cancel it because we saw that it worked. It's going to tell all the users to shut down. And then we'll just go back real quick and make sure a couple of things. One, that everything ran at least one time. It was working. So in the first one, in the English user, you can see it was working through all the tasks. It didn't quite get as far as contact form, but that's because we didn't leave it run very long. The Spanish, same thing. It got all the way almost to the contact form. And the admin user successfully logged in, which was the part I cared about the most. So now what we're going to do is spin up a more realistic load test. We're going to kick off 1,200 users. We're going to launch them at the rate of 2 a second. And they should all launch in about 10 minutes, but we'll let it run for about 20 minutes so that there's ample time for it to put some load on the system. So kicking that off, it would help if I accidentally wrote the collect. I always think of hatch rate with an R for rate, but it's H for hatch. So
I think you're missing a T on the 20 minutes.
We need a T for time.
And I think it's R2. That was correct.
Let's try this one more time.
There we go.
Alrighty. And with that, I'll stop the screen share so that Fabian can show us what this traffic looks like.
Great. Hello, let me share my screen now. So Google Chrome, share. Here we go. So we have I brought up here the Umami site. So for those not knowing it, it's a beautiful Drupal 9 brochure-like site. It's the Umami food magazine. It has articles, it has recipes, it has lots of nice things here, like a vegan chocolate and nut brownies. Like, if you want to do that right now, feel free while continue watching. And as you can see, we are now hitting the site already with quite some traffic, which we will see the site still performing pretty snappy. So that's really great. Now let's take a look at how this all looks in New Relic. So we're gonna use this default view New Relic here. And we have like two different views available now. There's a new view of New Relic that has been recently coming, and there's the old view. I personally like the old view a little bit better, so let's switch back. And that's also the one I got certified on. So I'm a New Relic certified professional. So what we can see here is we are starting to get traffic. So right now we are still at 19 RPM, so not that much yet. And because we don't want to wait lots and lots and lots of time, we just choose a different part of our time window. So we look at 6 hours ago. Then we see this big thing here screwing everything up. This kind of happens after we've run a few load tests. We still need to figure out what happens here actually. But let's just push out this outlier, and we can see here the load test we've already run. And we can see here, this was a 1,500 user test. This was a 750 user test. This was a test that actually did go up to 2,500 users. And if you look at the graphs, you can see two things that are interesting here. And the point is that you can see these graphs here are kind of flat. There's up and downs, obviously. But if you look, the database section and the PHP section are kind of the same. However, in this graph, what happened was the database did go off the roof. So just to show that again in isolation, essentially, let's just look at the database. So we can see the more users we put on it and the more we add on it, let's focus just on this load test real quick. The more users we had, essentially, the larger this did go here. And here we also show, so Pantheon Elite is great, and we have to understand one thing. Essentially, all that did go through and that Pantheon had to deal with are little things cleared by the cache of that admin user editing some content, the searches, and the contact form posts. Everything else essentially is already buffered out by the Pantheon Global CDN. So all the anonymous traffic we're not even seeing here, but that's how it should be, because most often when we
know that there's so many pages, Fabian, that some of the traffic still does get to Pantheon for a considerable amount of time.
Yeah, some traffic does get through, but at least it does not get through 1,000 times, because that's another advantage of CDNs like Pantheon Global CDN. They have a kind of shield feature. So if like 1,000 users coming in, then essentially only one user gets pushed through to the edge servers in the end. And the other part, however, that we are seeing is why we increase the number of users more and more, our scalability from here started to drop off. So the more users we put, actually, the less throughput we got. And the reason is that the database really did go to problematic heights here. And this authenticated traffic, or traffic that goes still through to the web server and is not fronted by the CDN, is so important, because often sites we deal with commerce sites where obviously you want people to purchase something, or they want to fill out a donation form, or they want to fill out a contact form, or even as simple as sign up for a newsletter. And all of those is data you then want to have. You don't want your database to only be like static, but you also, where Drupal is already really good, and a CDN can really help scale you up, but also for this authenticated traffic where users are actually interacting with the site. And this is kind of what we see in this example here, that the traffic is scaling way up and the database doesn't scale anymore. But let's take a quick look at a load test where it still did scale. So we go back to our 6-hour view, have this big chunk in here, the 750 users one. Just looking at that one. Okay, so here we have one where we put with a goose 750 users. We also see we have a nice little ramp up. This is something I like to do, and I like to do it also really much slower still. However, with so much fronted by the CDN, it was okay to go 2 users per second. And it's essentially showing how we get more and more and more and more users till we have this saturated, and then we keep kind of the load test running for a while, and then it goes off again. And when I do a test like this and not directly go to the many users, but have a slow ramp up, New Relic gives me something really great, and that's a scalability report. So if we go up here over to scalability, and it didn't take my zoom, that's the wrong one. Okay, let's go. Sometimes New Relic in the newer UI does not take the zoom you want. So let's take that again and click apply. And hopefully, if not, we just have to remember the times essentially. That is go one from 1 p.m. to 2:24. Yeah, that's the one we want. Slow ramp up. And now if we go to scalability, hopefully it keeps it. Yes, it does. Because what we want to see is we want to use time selection. And now we can see a really nice graph here up to 4K RPM. And we see this is kind of flat. And this is what we want. We want a flat graph ideally. So it can grow a little bit linearly, but it should be flat. So regardless how many more users I'm putting on it, I want a flat graph. And again, if we check the time window selection on the database here, we also see not as flat, but essentially we have this line here at 225 milliseconds. And here we have also this kind of wall that we've hit. However, if we look back into the larger time window and look at this very first test where we really stressed out the system, to take it. Yeah, now it takes it. Apply 12.11.107. Where we had this scalability problem, which was also clearly visible here, we can also see this scalability problem now clearly here. Again, we use the time window selection. CPU is kind of flat, but if you look at the database and the time window selection, we see it goes all over. But we also see something really interesting. So we have this same line at 200 milliseconds, and then we go up and go over to the 400 milliseconds, and then we go down again. Why is that? The reason is the number of users, and that's not really shown here, but the concurrency at 3K users in the end was much larger. So essentially we just cut off the graph here, and this is our problem right here and there. So this is how you read the scalability report, but let's now look at the live view. So because our load test is running, and here we go. This is a test that will be running up to 2,200 users, 1,200 users, and we'll show it.
100 users. It's almost that scale.
Oh, we are almost there already. Perfect. Great. So we can see we are scaling nicely up here. And again, the RPM is starting. And we didn't want to use more time here, but with Goose, you can even use a fraction of a user. So we can use, for example, 0.2, which we did earlier last week, to really show a very slow ramp up, and that gives you lots of great information. But now let's look at some of the traces, because essentially when you're running such a load test, you'll always have some requests that are slow. And that gives you a great ability to find problems on the side. Essentially, just to show real quick of what we have here, there's a distributed tracing, which we don't have because there's no things for that. Then we have this browser application, the service, MySQL, Redis, and external. That's essentially how the system is built, gives you a great overview over the hardware used. Then there's the edge cache clearer, which we are also contacting sometimes when we are editing content and changing it. There's all the transactions like a node view controller, the contact controller for the contact page, search controller for searches, an empty form controller for showing that, and a view page controller. So there's lots of things, and even our darling, the page cache of Drupal, serving Drupal since Drupal 3 well and nicely. Yeah, and we can see page cache is really performing really well. We don't have too much throughput here, but we can see essentially all page cache does is a Redis connect and a Redis get, and that's it. So no slow traces. And we see on average it's around 17 milliseconds per request. So this is all you can see here. And yeah, those are the responses where Jeremy said that are still getting through. Here we see some like 36 RPM. It's a fraction that hits page cache, but still Drupal is protecting us. So it's pretty nice. Then we have, for example, the node view controller. And now we see something interesting. New Relic immediately shows us what's going on here. So we have this controller view, and this is essentially the PHP code that's running. But there we have this one thing that looks really interesting. That's Node revision select. So this removes the response time, and we see this makes a huge difference in what we are seeing here. Then we have key value select. We still need to build a module, or a module still needs to be finished essentially to front the key value store with Redis, because a lot of that is config reads, and a lot of those config reads are repeatable. So they could be cached perfectly. Something to do here. So, okay, let's assume we had that done. Path alias select. Okay, path alias was changed in entities already, but seemingly not yet having the entity cache. Maybe there's something possible there. So that's another candidate for caching. And then we have node revision body select, but it's tiny, so let's remove that so we even see it. Node field revision select. Okay, that's that, and then there's other. But essentially we can see the biggest problem here is the node revision select. And now we can also see this in a breakdown. We spend 78% of the time on the node view controller for an authenticated user that's looking at this to see this. So
How do you
now
know that's the authenticated users and not anybody else? You said it's an authenticated user. How do you know it's an authenticated user?
Because the probability of it being an authenticated user is much, much higher than it's just being a random user for the frequency of calls we have here. We'll also see in a moment. So let's take a look at this trace. Maybe we see something interesting. So now we look at one trace where we have this kind of problem with the node revision select, where essentially 96% of time is spent here. And we can also see there's some time spent in the renderer, Redis, Theme Manager, but that's all not our problem. It's really node revision that's showing this. Now we need to figure out why. First of all, this might be just that this is a very slow query. So this is the query, and we can see if you read some other Tag1 articles, there's a left outer join in here, and then there's an inner join. And while joins are fine on databases, inner joins are usually much cheaper than if you're doing left joins or left outer joins. So there might be a query that maybe is just bad because it performs really bad. That's what we can see here. And now we can look, because it took so long, New Relic is essentially providing us here with the database view, and we can look at where this is called. We call this latest revision, NT-View Builder. So yeah, this seems to be something deep in. But here's something interesting. Here's a module, that's quick edit module. So there might be something that's doing that. And there we see it's quick edit NT-View alter. We could have come to the same conclusion using a different trace, just looking at the call stack, which is essentially what each function calls each. And then again, we go way down here and see the node revision select here, and can go back, and here seeing it's a quick edit NT-View alter that is creating that. And especially this function is latest revision, get latest revision ID. This seems to be one that's really slow and screwing us up here. Now the question is, does quick edit entity even need the latest revision, or would it be okay, for example, it being the default revision? Maybe that would be an easy optimization we could be doing, because each entity knows if it's the current revision or if it's a later revision. So we'll see what happens like that. But for now, what we can see is we've identified successfully that this quick edit NT-View alter is making things slower. And that brings us to this, that this most likely is an authenticated user, and most likely even an authenticated admin user, because probably only an admin user would have this quick edit. However, imagine a site with a huge group or whatever, and you were like, hey, I want to build like a little Jira-like interface, and you have lots of users in the forum where they can essentially just use quick edits to input a title instead of directly having to edit their post, and then you're using quick edit for normal authenticated users, non-admin users, and then you would run into this exact performance problem. So it's not just pure theoretical, but it's something that happens. And while it here only happens on scale, if you have like a slower MySQL instance because you're using like a Lando or DDEV or whatever local Docker instance locally, then you could definitely also be hitting this, because it can happen that, yeah, this is showing that. So this is what we could be getting out of this load test already. So let's take a look at some more. For example, we can now take a look at the context side page. And there we fortunately don't have revisions, but again, we have the key value select showing up. So if you want to scale the database, we want to remove all the queries as much as possible. And we see essentially the big things in core that's still hitting MySQL, and in Drupal 7 we had kind of the goal of no database access at all. For example, key value select, parse alias select, menu tree select, config select, and then in the end we only have Redis get and other. So there's that. And here we see a lot of the code is essentially just PHP, where we're spending most of the time, and then the queries are neglectable. But for scaling, it's much easier to scale up Redis than to scale up a database, besides just buying a bigger database, which you can do on various cloud platforms, obviously. And search controller, just recently we had the question of, hey, what about this Drupal core search? Is it fast enough? Because in older versions of Drupal, core search was a little bit of like, maybe the search query isn't as optimal for that. And now we have Search API, which for example also has a database backend. So what about core search? And it turns out core search actually is pretty okay, because it's the search index select query is not much time of the whole thing. In average, it takes 2 milliseconds. So, and this is under load, so that's fine. Core search seems to be pretty okay to use, and it does also scale up. So even if we get more throughput for the search query, we get definitely the same response time. There's some max values, so that's always when the database is a little bit overloaded, like max 353 milliseconds, etc., which again points to gives the database less to do, and you have more fun with your search queries or other important queries that need to be live, and so on. And this is the databases view of New Relic, which is also really interesting because you can see all database overview. Again, node revision select shows up, key value, parse alias, and just then Redis and menu tree select. So those would be the 3 things on the side we can optimize now and concentrate on optimizing to then run another load test and find the next problems. And here you can see the most time consuming queries of all. We can also sort by the slowest query time. So node revision, watchdog. Yeah, here's watchdog delete. So we're using right now dblog, seemingly. Should probably replace that with syslog, so we are not logging to the database, which can take some time. And that's only running on Drush, however, so not too big of a problem. Then we have Pantheon, queues, key value expire. It's also an interesting thing, which we could move to Redis probably, because there's a module for that, for the expiring key value stored to using that, and search index select. Again, we can look at the all database operations table. We can sort by throughput, for example. So select is the often, key value select is the most often, parse alias menu tree. So we see key value is queried much more often than, for example, the node revision, but node revision is much slower, so that might just be a bad query. Have to look at how it's built, essentially. Jeremy, do you have questions so far?
I had some. I should have written them down because I've moved on with my brain. Sorry.
I'm just
No
thinking,
problem.
how did people do all this without New Relic?
It's almost impossible to do it without New Relic. I don't know. New Relic is still one of my most favorite tools, and I was beyond delighted when they both open sourced their PHP agent, as well as made the pricing much more fair, I would say, because it's now based on the data you are accumulating and less on how many instances you're running it on, which in a Docker world with lots of thousands of instances would have no longer scaled. So it was a good move by them, in my opinion, to change their licensing model there. But yeah, it's great. And with Pantheon, you get New Relic automatically as part of your plan. So this is just great. And you see Pantheon is scaling perfectly up. We accidentally did one load test on dev. And then Pantheon was like, this instance might be a little bit too small for this kind of traffic. And then they scaled it up even a little bit. So it was fun that they immediately looked at the traffic and automatically saw something is wrong and scaled up. And this is happening with Elite as well. So yeah, and we can see how much more we can push this essentially in terms of concurrency once we have solved this database problems. And we could also essentially disable the external CDN and then do a load test for just the anonymous part, and then look at a little bit more into Drupal there. But we probably also need to disable page cache and dynamic page cache because, well, we have a lot of great caches in Drupal by now, and they all essentially allow Drupal to scale so well. Well, here's like a little Drupal views thing. So we see recipe collections right now takes the most time in that, and it's also called quite a lot. Probably one of our admin users is calling that. Then there's an articles sidebar view, which we have here with much smaller call count. So you can see which of your views are essentially working well, which are not working well. We can see recipes is the most slowest average call time view right now. Function call count, recipe collections is called the most. So yeah, this is
the load test. Good job, because you're right. The recipe page is one of the ones that the logged in user does, and the only other one it calls is the front page, other than editing a node and the initial login, of course.
Yep. Then there's Drupal hooks, which is also really interesting, and I love New Relic that they implement already for Drupal 7 and now for Drupal 8, 9, 10. Also this hooks implementation essentially, because we can immediately see that hook NTXS is consuming the most time in the whole system. So probably there's something in the entity system, access system, that takes a little bit longer. Then we have here language fallback candidate anti-view alter, which also takes some time and called quite a lot. And then we have page attachments, form alter, obviously, etc. So again, we can look at a lot at and how much time is spent, which is kind of the energy cost you're paying, or the payment in terms of CPU cycles. So if you're, for example, on an EC2 instance where you have a certain number of cycles, then this most time consuming directly relates to that. The more cycles you spend, the more money, essentially, unless you're on a fixed pay host like Pantheon or other cloud. Then we see the slowest average call time is the views data hook, not called a lot. That was probably just some drush or whatever, cron job. But ND-view alter is also called a lot, and we know why. We know because of quick edit, because quick edit makes that slower, and this brings the average way down. Function call count, field access, NT-access. So we can again get a lot of ideas of what's taking how long, what's just called a lot, but does not really take long, like this theme suggestions block. It's called a lot, but it's just 0.0053 milliseconds, so really does not matter. We can also overall see which module is the most time consuming, and here we can see again, as we are a logged in admin user, content moderation is taking the top spot here, but it's also called quite a lot. And then content translation is next. So again, we get a nice idea and overview of what takes what. And so content translation maybe also is doing some stuff that's a little bit more time consuming. And again, we have those things. And here, again, quick edit shows up as a top spot as slowest average call time. So we know something is up as that. We already figured out what, but if we hadn't yet for the traces, this would have given us another entry point of finding, hey, what's going on with the system? Why is this performing so bad? Then we have errors here. Pantheon is really great that regardless how much traffic you put, there's no errors here. if we essentially sustain all web hosts and with even larger instance, then this is ended before New Relic even sees it. This had advantages and disadvantages at the same time. Usually it just means that you just have to wait a little bit longer. Then we have like this violations is if you set some performance metrics that you want to hit. Deployment's really useful if you say, hey, with this last release, really we regressed, and we can maybe show that some other time when we improve Drupal core and hopefully fix those problems. And so there's lots of nice things. Yeah, and Thread Profiler isn't available, obviously. There's more reports which you can go more in, but that would be kind of like the nice overview of what we have. Yeah, I think I would be kind of through. We can also look at our load test, and since 30 minutes ago, we are still running a little bit, but shortly wrapping up. So I think we should be wrapping up also from the load test perspective. And again, we can see we hit this 3.72K. And then we did go a little bit down, but overall the scalability till 1,200 users is still fine. We had here a little bit of a peak, could now analyze this. Sometimes you find things by chance. So we also have some more way slower queries with the larger thing. One here even 94 seconds. Let's see what's up with that. And here we see just this response sent. This essentially meant this webhead tried to send a response but couldn't because something else was blocking it for being scheduled again. So it was just waiting for a very, very long time to actually send out the response. So this is kind of like a false positive, which is why I like to also look at the traces that I'm seeing while the load test is just ramping up and not just when it's running for a very long time already. So if we looked at the more first part of this test, and I have to do it here again because it else does not take it.
It also just finished for what it's worth.
Pardon?
The load test did just finish as well.
Yeah, perfect.
Yeah, for 20 minutes.
And we look at the transactions within this time frame. In summary, then we see here we not yet had those crazy requests, just 16 6 sections. And could now check again, but it's probably just node revision again. Yeah, node revision select. So yeah, this is where we stop essentially because we need to fix this problem first and then we can continue. Oh, and one last thing, very important. If you look at database thing and you see lots of cache key, cache node, cache whatever things, then your Redis is not set up correctly. That was what we had first and we fixed it. And then it was much quicker already. So yeah.
Awesome. That was really cool. I think, what fascinates me is that there's so many components to this, knowing how to set up a load test, and how to properly configure, anonymous versus authenticated traffic and how you split out your users, how to interpret the results and find the problem. You need to fix that problem before you, move on to the next set of testing. So we're going to continue to cover topics like this. We've touched on a lot of what I just mentioned in conference presentations and other Tag One team talks that give you insight into how to plan your load test and the process. So it was really great to cover this because we haven't really dug into this aspect much yet. You can check out tagone.com/goose for more information on those other topics. You can find the documentation for Goose, the GitHub links, as well as our other Tag One team talks, blogs, and conference presentations. If you guys have any questions about Goose, please use the GitHub issue queue. If you like this talk, please remember to upvote, subscribe, and share it out. You can check out past Tag One team talks at tagone.com/tag1teamtalks. As always, we'd love your feedback on this show. If there are other topics that you'd like us to cover with Goose or in general, please email us at ttt@tagone.com. And again, Jeremy, Fabian, thank you guys so much for joining us and walking us through that. That was really cool to watch. I want to say a huge thank you again to Pantheon for providing all of the hardware for our Drupal instances and their global CDN. I saw our last CDN bill, so I'm particularly grateful. We throw a lot of traffic at these sites in our tests, and we're really appreciative for that. And of course, everybody who tuned in and joined us today, thank you all for joining us. We'll see you soon.